Okay, so what we have here is a new kind of algebraic system where we have an equation that's got function names in the equation. So we're not looking for, when we're saying solution in this case, we're not looking for a solution of x, we're looking for a functional solution. A solution that is itself a function and not just x values. So all we want to do is take this y, and this tells us we need to find the second derivative. So the first derivative is negative cosine x. The second derivative is sine x. So now we take this second derivative and plug it in, and we take the original function and plug it in where it says we have the original function. So we have sine x minus a negative sine x is equal to 0. So sine x plus sine x, and our question is that equal to 0? And no, 2 sine x is not equal to 0. There are specific x values that do work, but we're looking for a whole function as a solution in this case. So this function will not work in this situation. So for this situation, we're trying now a new function to see if this is going to work as a solution. So again, we want to find the second derivative. So we have 4e to the negative x times negative 1. That's a chain rule problem. So that's really negative 4e to the negative x. And then the second derivative would be a positive 4e to the negative x, because we'd get another factor of negative 1 here. So it'd cancel out this negative that we got. So now we take this and we plug it in here. And we take this and we plug it in here. And we get 4e to the negative x minus 4e to the negative x, and that does equal 0. So what that means is that this is a solution to this differential equation. And you shouldn't be apprehensive about this new term, differential equation. It's just an equation with derivatives in it. That's all that means. Okay, so new function. Just like last time, we want to get to the second derivative. So we get a negative ce to the negative x here for the first derivative. Then the second derivative is a positive ce to the negative x. So we plug that in, we get ce to the negative x minus ce to the negative x, which does equal 0. So it checks out. This is a solution. So now you might say, well, what's the difference between this and the one we just did with the 4? Let me go to a new page. This with the 4 is called, oops, hold on, sorry. This is called a general solution. Sorry, other way around. This is called a particular solution. Is it particular or Yeah, that's supposed to be an R. Sorry, that's an... I'm also a little bit dyslexic. Okay, so with the 4 is a particular solution, and with the c is a general solution. Okay, so verifying that something is a general solution is just saying, well, this is the general solution, but I want you to show me that it is. So, well, we know what x is. It's just x. We know what y is because it tells us here. So we need to find out y prime in this one, or the first derivative. So y prime, let's say that y is c times x to the negative 1. So y prime is negative cx to the negative 2, or negative c over x squared. So then when we plug it back into this equation, we have x times negative c over x squared plus c over x equals 0. So here we have an x that will cancel with one of the x's here, and we get negative c over x plus c over x is equal to 0. And that does cancel itself out, so we get 0 equals 0. So that's how we verify if something is a general solution. Okay, so here we have a differential equation, and we've got a supposed solution for it, a supposed general solution. So we want to verify that solution and then find the particular solution given these initial conditions. So we've got an x, we've got a y prime, and we've got a y, so that means we need to find a y prime. So y prime is going to be 3cx squared, y prime. So then we have x times y prime minus 3 times y equals 0. So here we've got an x and we've got an x squared, so we can turn that into an x to the third minus 3cx to the third equals 0. So we've just verified that that is a solution because we end up with 0 equals 0. So this is indeed a solution. So to find out what the particular solution is, we want to use this information. So we have y equals cx to the third, and y equals 2 when x equals negative 3. So then we get 2 equals c times negative 27. So then c equals 2, or negative 2 over 27. So then the actual general solution is y equals negative 2 over 27x to the third.